Assalamualaikum. Let us look at this slide. We are going to learn and see the relationship between displacement time graph and velocity time graph and acceleration time graph. And we are going to see how they are related to each other. Okay, let's say we have this point. This is the starting point, and this is the car. And the car is stationary, and it is 5 meters from the starting point. So can you tell me how the S time graph looks like? This is just a simple thing here. Let's say this is 5 on S axis. Since the distance doesn't change, it keeps at 5 meters, it stays there. So it should be a straight line like this. Even the time passes, the displacement does not increase. So we have a straight flat line like that. Now look at this graph, VT graph. Since the object is stationary, so it does not have any velocity. So the velocity is 0. As we know that the gradient for this graph is velocity. So the gradient for a flat line is 0. So the velocity is 0. So it should be like this. And the acceleration is also 0 because stationary object does not have any acceleration. Now let us look at the second situation here. Now we have a car, for example. Okay, this car. And the car is moving at constant velocity like this. Let's say it's moving like this. It is not accelerating. It is just moving at constant velocity. So when it's moving, the displacement will increase. The displacement here will increase at constant rate like this. As time passes, the displacement also increases. So we have a straight line like that. As we know, the gradient for this graph is velocity. So if you calculate the gradient for this graph, you are going to get one number. Okay, let's try to put a number here. Let's say this is 4, this is 2. So the gradient is 2. So you can calculate yourself. So you should get 2 over here, a straight line. Okay. Since the velocity is constant, and as we know that gradient for VT graph is acceleration, flat line means the gradient is 0, so the acceleration is 0. Okay, you can see here. Okay, I hope you understand so far, and let us move on to the next slide. Okay, now look at this car. Okay, let's say it is now accelerating. Initially, it is moving slowly, and then the velocity increases, and faster, like that. And then let us try to draw the graph there. Now it should be like this. Okay, you can see here the gradient will increase. You should start from 0 here, usually. And then when you draw a tangential line and you measure or you calculate the gradient, you can see the gradient increases constantly. For example, the gradient here is 2 meters per second. This one is 4, this one is 6. So when you plot on VT graph, it should be a straight line like this. And when you convert to AT graph, as we know, the gradient for this graph is the acceleration. So the you're going to get one value here for the gradient, and the value is here, straight line. Okay. And in the last example here, look at the car here. Now the car is moving and it is accelerating also, but this time the acceleration increases much faster. For example, when we draw a line like this, okay, now you see the gradient increases not at constant rate. For example, let's say this is 1, this is 5 meter per second, this is 5 meter per second, and the gradient here is 10 meter per second, for example. Then when you draw velocity time graph, it should be a curve like this. So this is 1, this is 5, and this is 10 over here. Then you do the same thing like this one, then you are going to get a straight line for ET graph, just like this one. Okay, I hope you learned something from this video.